A half adder is something that adds 2 bits. So let's say 2 bits AB 0001 1011 sum and carry, or we can say carry out if any. So 0 plus 0 is a 0 and carry is 0. 0 plus 1, the sum is 1, carry is 0. 1 plus 0 is 1, carry is 0. 1 plus 1 is 2, that means 1 0. So 0 goes in the sum and 1 for carry. So this is the half adder, that's what it does. So basically if I write the sum of product here for S, that will be A bar B for this one, and this one plus A B bar. That's what this one is, and we know that this expression is actually an XOR expression. A bar B plus A B bar is an XOR. That's the meaning of an XOR. If you look at the XOR truth table, that's what an XOR truth table is. This one looks like that because when the inputs are the same, 2 bits are the same, the output is 0. When they're different, the output is 1. That's what an XOR is. Anyway, so C is just that one, so AB. So if we implement it, it will be just like that. So this is XOR gate for the S, AB, and then again if I take it from here, this is the carry out. Now coming to full adder, here we also consider the carry in of a previous stage, as we can say. So A, B, C in, and then again output sum and carry out. So let's just 001 010 011 100 101 110 and then 111. So when 000 is added, output is 0, carry out is also 0. This is 1 0, again 1 0, just like the previous one. 1 1 is 2, so sum is 0, carry out is 1. 1 0 is 1 again, 0. This is again 2, so 1. This is again 2, 1 here, and this one is actually 1 here because this is 3. 1 plus 1 plus 1 is a 3, that is 1 for sum and 1 for carry. So now if I look at the sum expression and I write the sum of products here, this one, this one, this one and this one. So this one is A bar, B bar, and then C in plus A bar, B, C in bar, plus for the third one, which is this one, A, B bar, C in bar, and the last one is A, B, C in. So if I take these two, it is becoming A bar, B bar plus AB and C in. So this one and this one, and for these two, if I take the C in out, C in bar out, becomes A bar B plus A B bar. Now this part is again A XOR B, so I will quickly erase this truth. Oh, I needed the carry out though, so yeah. So anyway, I will try writing here somewhere. This part is basically A XOR B, and this one is actually A X NOR B, that is just the invert of XOR. So this is this, we know from the definition, XNOR is just the invert of XOR. So when both the inputs are the same, the output is 1, and when they are different, the output is 0. That's the XNOR. So basically XNOR is nothing but a invert of XOR. So this whole thing we can write, I will just erase the previous line now because there I have some space. So this thing I can write A XOR B invert, because this is actually XNOR, this part, and then C in plus C in invert A XOR B. So if I think that A XOR B is like X or something, just to make it simple, so then this is becoming X bar C in plus C in bar X. Now this whole thing is again X XOR C in, because this is again like A bar B plus A bar B plus A B bar. That's what it is. So finally this whole expression is becoming like that. It is this part. So this is becoming, instead of X, if I write this thing, so this is the output of a sum, of a full output of the sum of a full adder. That's what this one is. Now looking at the other one, which is the carry, I will write the sum of product for the carry expression. So again there are 4 terms there. For the first one, this is this one, which is A bar B C in, plus this one is A B bar C in, plus this one, which is A B C in bar, plus the final one, which is A B C in. So again, if I take these two out, in these two, from these two, if I take the C in bar common, so this is becoming A bar B plus AB bar C in here, plus here from this one and this one, if I take AB, this is becoming C in plus C in bar. So this is actually C out, carry out, the expression is for. So this part is again A XOR B. So I can write, I will just erase the previous line, and it will become A XOR B C in here, and this part essentially is 1 because A plus B bar plus AB. So this is the expression for carry out for a full adder, and they're easily implementable using, this one is an XOR gate, AND gate, and then OR gate with again AND gate. And the sum expression was obviously 2 XOR combination, so A XOR B XOR C in, so just 2 XOR gates which result in the, which will give the sum output. So basically a half adder is just adding 2 bits without considering any previous stage, and then getting as output the sum and the carry out, while full adder is considering a carry in as well, so adding 2 bit with a carry in from the previous stage, and then having an output of sum and carry out. So full adders can be added in stages to get a multiple bit addition. So if I want to have something like this, if I want to add like A0, A1, A2, A3 with B0, B1, B2, B3, so in this particular case what I'm trying to say is this thing B3, so this is probably MSB and this is LSB. So basically if I use 4 full adders, I can have these 4 bit additions with 4 full adders then connected in as cascading them. I can get the 4 outputs. 4 sum outputs will be the 4 bit sum results, and the carry out of each one will be carry on to the next stage, so the higher significant stage. So basically the connection will be something like that. If I have a full adder here, I will just draw in block. So I have a full adder, so this is A3 is a B3, and this is giving a carry out, and here I am having a sum 3, and this is carry out. This carry out will go as carry in. Here carry in will be 0 for the first stage. So again the A3 and B3, these are the least significant, and A0, B0 is the most significant. So here I will have A2, B2, and this is carry in of this stage is going to the carry out of this stage. The first stage is going to the carry in of the second stage, and this is how it will cascade to get the whole 4 bits. So yeah, basically I will have 4 4-bit adders, and the carry out will go over this way, and the final one's carry out will be just a carry out. And here I will have S3, S2, S1, S0. So basically these are the carriers. I will just have one output here though. Yeah, so yeah, and the carry out output is coming here. So this is carry out 2, carry out 1, like that, and carry out 0, which is the final carry out here. So this is a 4-bit full adder made by cascading 4-bit adder, made by cascading 4 2-bit adders. The bits are A0, A1, A2, A3, and B0, B1, B2, B3, A0, B0 are the MSB, and A3, B3 are the LSB. So yeah, it's like that. So the sums are here, S0, S1, S2, S3, and this is carry in for the first one, and this is the carry out here, and then this carry out of the third of the least significant bit is connected to the carry in of the second bit, so the second most least significant bit. This is the carry in there, and similarly it's going there. So carry out, carry in, carry out, carry in, and this is the final carry here, and this is the carry in, which will be, for 4-bit case it has to be grounded, so it's 0. So yeah, this is just I drew it properly to show the connection diagram.